So I'm going to go over some examples of how to do this project. So let's look at the first part, categorical. Remember, category was non-quantitative data sets, right? Things that, that used words and features rather than quantities. Remember, a zip code, you might think would be a quantitative data set, but it's not. A zip code is categorical because a zip code represents a region, right? It doesn't represent an actual number like weight. So we go to our animal data set, and on line 15, right, it sets the table, and it has name, species, sex, age, fixed, legs, pounds, and weeks. Now, you might need to look at it and see what does that really translate to? So you type in the animals table, and anything with quotes is categorical, right? Anything with a number is a number. I would say legs could also be, we can use like the same kind of, we could put in the categorical framework because it's not like something like pounds or weeks where the numbers are either 4, 0, and I think there might be a tarantula in there, so 8. So, but the point is, we have a lot to work with here if we only need to make 2. So I see species. I think I'm going to make a species. So I'm going to go to bar chart. And both bar chart and pie chart only take 2 arguments. They take in the table, and then they take in the column name as a string. Remember, a string is with quotes. So I'm going to do species. Species. Okay, hit enter. Very nice, very nice. So what I'm going to do now is I'm going to go to my snipping tool, right? And you might have another tool on your computer. If you have a Microsoft computer, snipping tool is the easiest thing to work with. Hit new. It's gray in the back. All you do is just go down and drag. And there we go. Hit edit, copy. Go in here and you paste in the image. Very nice. And I didn't mean for it to be here, but it's good that we see that 15 is dog. And we see that dogs are the largest, right? The most species represented. Why did you make this chart? To see the different types of animals in the shelter, right? What does this chart tell us? It tells us that the dogs are the highest represented animal. Snails. There is only one snail and tarantula, right? Cats are the second highest represented. Right? I mean, and it's actually, when we go down to findings, right? What we could write is, maybe the shelter has to think about, like because the number of lizard, like the lizard, the rabbit, the snail, and the tarantula is so small. I mean, if they just were exclusively for dogs and cats, they could focus their funding on, on making a really great space for dogs and cats, on getting people to adopt dogs and cats. But yeah, that's it, right? Like this is just something that we could talk about, right? Here we're just explaining the facts, right? With findings, we're kind of inferring, right? We could say some things that might be useful to our client, but here we just want to present the facts, right? This is why I love data science. So I'll leave the other chart up to you, right? How to do it. I'm going to go now to quantitative visualization, right? So it's asking for a histogram. So a histogram, we want to use quantitative, which means that you can do, okay, if you have an issue like this where I can't get rid of this, all you have to do is hit Control minus a couple of times, and then, oh, I guess for me I'll have to do it a bunch of times. Oh, it didn't work that way. Interesting. Oh, that's big. Okay, well, reload. I'm gonna just pause it. And we're back. Sorry about that. Now I'm going to make a histogram, and histogram takes in three. It takes in the table. It takes in the column. Remember when I saw the table, pounds and weeks were the quantitative, right? The numbers. I really highly suggest that legs you can use it as a qualitative, right? You can categorical data and bin width. So I think if I remember correctly, it's animals got adopted pretty quickly there, but one is too big. I'm going to make the bin width a little faster. I'm going to use my shortcut, hit the up button, and it goes through. And I'm going to make it maybe 4. Let's see if that's nicer. That's a little nicer. That's a little nicer. So I'm going to do the same thing I did before, but this time I'm going to be smart. And as soon as I get my image, I am canceling this out. So I am taking in my axes, right? So the count and the weeks. Bam, got that. Now that I look at it though, this is a little messy down here, so which I don't like that much. Let's try to see. It's going by 2.5s. So bring it up again. This time let's make it go by 8s. No, that's definitely not okay. Up again, let's make it go by 5s. Much better. This is much better. Okay, so I'm going to go to my snipping tool. The count and the weeks, make sure that's in there. Edit, copy, done. X that out so I can come back to it easier. All right, so I come in here, hit Control V, and it's in there, nice and big. Why did you make this chart? To see the data for how long it takes to adopt an animal at the shelter. Describe the data set. It is, if I drew a line over here, right, like if I went like this, I would see that there's a tail on the right. The data is right skewed with a peak between 0 and 5 weeks. So we can say that most of the animals get adopted between 0 and 5 weeks, right? And the majority between 0 and 10. But then we have some animals that it takes a little longer, right? What does this chart tell us? That most of the animals get adopted within the first month. The majority of them are adopted by 10 weeks. There are a few animals that it takes almost 35 weeks, right? And that would be interesting, right? Like maybe you could look at like using social media, to kind of boost it. So for these animals, maybe you could do a higher analysis to see which animals are not getting adopted. Are they the larger animals? Are they smaller animals? But what's nice is you can just you can tell the shelter that maybe that they only have to build a space for an animal between 0 and 10 weeks, and to buy enough food where we're only keeping the animals between 0 and 10 weeks, so you don't have to prepare. Okay, now we have to make 2 box plots with a 5-number summary, and Analyze at least 2 quantitative columns. So remember, quantitative means that we can only use the numbers and measure your findings. So we go back to the data. Now this is interesting because there's pounds and weeks are the 2 quantitative data sets. So we're going to have to do both. I love modified box plots because they give you all this extra data. And then remember, you take in it's almost just like a bar chart or a pie chart. You take in the table and the columns. So let's do weeks. Hit enter. Modified box plot, not plots. All right. And here's our modified box plot. Now you see this right here. This are our 2 outliers over here, right? And this is the 5-number summary that they were talking about. All right, so I'm going to go to my snipping tool, hit new, and I'm going to snip from here to make sure I get my 5-number box plot, and take that, edit, copy. Okay, go back into my Word document. And I'm going to paste it right in here. And if you want to resize it, you can. Yeah. Or if you want to bring this down, you can go to insert, and I like to do a page break. And then you can start a new one. And okay, why did you make this chart? To see patterns for adoption, for animal adoption at the shelter. So we have 2 outliers, right? 24 and 30. That most of the pets get adopted. Oh, you see this? Look at this. Oh, much more information, right? We can say that almost all the pets are adopted within 10 weeks, right? And remember how a box plot works is it breaks everything into 25%. So you could even say that 50, so this right here is quartile 1 here. So the minimum is 1. So, it takes 1 week for the lowest it took was 1 week. Then the next quartile is 2.5. And then, so from here to here, right? So that's quartile 1. And so what happens here is this is 25%. So 25% of your pets are adopted between 1 and 2.5 weeks. And then as I go over more, I can add another 25%. So between 1 and 4 weeks, which is a month, 50% of the animals are adopted. All right, so we can use that, right? So we can say 50% of the animals are adopted within a month, right? And then we have quartile 3. So we have our minimum, quartile 1, quartile 2, quartile 3, and quartile 4, which is here. Maximum. All right, and so we can also say then, between 7, which is right here, and 10, right? That's another 25%. But I think this is enough information right here, right? We have our 2 outliers. We have, most of the animals are right in here. So anything outside these whiskers are outliers. Okay, what does this chart tell us? It tells us that most of the animals are adopted within within 2 months. That we can say that there's the adoption rate is around that time. So and now you are going to have to do another box plot for another quantitative data piece. And then finally, the findings, I want to see what you can come up with on your own. Just what conclusions do you have about your findings? Why are your findings important? How can they be used? What are possible threats to the validity of your data, right? So what are so remember we talked about making sure our data is valid. Especially when we talked about the voter situation, voter suppression, voter fraud, right? The importance of integrity. So it's important to talk about possible threats, right? And then what new questions do your findings raise? What kind of questions can you come up? These shouldn't be that long. What conclusions can you have? I would expect a paragraph, 3 sentences. Why are you, if it's less, it's not gonna, be bad. I just want to see some thinking. Why are your findings important? How can they be used? Again, a paragraph of 3 sentences. What are possible threats? You can just list these, and what new questions do you find do you have raised? Again, it could be one question, it could be many questions. It's more important the quality than the quantity for me. All right. If you have any questions on this project, feel free to reach out. This is a very long video, but it was optional, so I hope it was helpful. Okay, take care.